Hey guys, Mr. Middleton here. Today we're going to talk about solving quadratics by completing the square. By the end of this lesson you should be able to find a missing term that completes a perfect square trinomial, and then you should also be able to solve a quadratic by completing the square. Okay, so we're going to learn how to find that missing term, and we're also going to learn how to use that in order to solve quadratics. Okay, just to review something important, we have x plus 3 squared. Remember that we can simplify this. I always like to rewrite it as x plus 3 times x plus 3. You could do the box method like we've been known to do in class, or you could FOIL. If you FOIL x times x is x squared, x times 3, which is 3x. Do the same thing for the second term, another 3x, and for the third term, 3 times 3, which is 9. Add our like terms together, we have x squared plus 6x plus 9. Okay, so x squared plus 6x plus 9, same as x plus 3. Okay, this is an example of a perfect square trinomial. Okay, what we're going to do today is we're going to learn how to, and we're going to use perfect square trinomials in order to solve quadratic equations. Okay, and in some cases we might be fortunate to have perfect square trinomials, but if we do not have perfect square trinomials, we will make them. Okay, we'll create them using algebra rules so that we can square root each side and solve for our answer. Okay, the benefit of this, completing the square, there's a process that's kind of helpful for us, and it's a continuous, consistent process. We'll do the same thing almost each time, which can be helpful, especially if some people don't like factoring. It also helps us to use square roots when there's a b. You can think of completing the square as using square roots when there's a b. And it also leads us into the quadratic formula, which we'll talk about next week or in the next few lessons. Okay. Okay, so here we go. We are going to solve a quadratic using square roots. Okay, and I'll show you how we can use square roots if there is a b value. Okay. The way that we can solve quadratics if there's using square roots if there's a b value is if there is a perfect square. So in our first section of solving without graphing, we used square roots, and b was always 0, which helps us out. But for this first part, we have x squared plus 8x plus 16 equals 25. In this case, b is not 0. B is actually 8. Now, we should probably lean towards factoring this because we can factor it. If we do try to factor it up, I want you guys to notice that this is a perfect square trinomial. You see that we would try to find two numbers that multiply to give us 16, and at the same time add to give us 8. Those two numbers would be 16. Those two numbers would be 4 and 4. Okay, and so what we have here is actually x plus 4 squared on this left side. X plus 4 squared equals 25 because we haven't changed anything on the right side. Alright, now having rewritten this left side this way, it allows us to take the square root of it. Okay, because the square root of x plus 4 squared is x plus 4. Kind of cancels this out. It cancels this out. So x plus 4 now equals, don't say 5, plus or minus 5. Okay, so x plus 4 equals plus or minus 5. And now we need to get x by itself, and we'll do that by subtracting 4 from each side. Gotta use my spacing here. So up here we have x will equal, now this is really important. I'm moving it up here so make sure you're paying attention. This is negative 4 plus or minus 5. Okay, it's really easy to get these signs all switched off and not really know what's happening. But we have negative 4 plus or minus 5. So in one case we'll have negative 4 plus 5. In another case we'll have negative 4 minus 5. Okay, so we're separating those signs in order to see what these numbers are. So negative 4 plus 5 will give us 1. Negative 4 minus 5 will give us negative 9. And those are our values that solve this quadratic. Okay, and so you see that we have solved this quadratic using square roots, but because we had a perfect square trinomial. Okay, let's do the same thing for number 2. Number 2, if we're looking at it, again, our natural intuition probably would be to factor this, but when we see that we need to find two numbers that multiply to give us 25 and add to give us negative 10, those two numbers should be negative 5 and negative 5. Okay, so this will be a perfect square. We'll have, and I'm going to use this top line this time so I don't have to rewrite it. We will have x minus 5 squared. Okay, equals 16. Again, because of the square, we can square root both sides now. And so x minus 5 will equal plus or minus 4. So in this case now, we would, to get x by itself, add 5 to each side. So we'd have x equals 5 plus 4. We'd also have x equals 5 minus 4. I'll rewrite that answer up here. So that means x would equal 9 and 1. Guess good problems I picked out, they look the same. At least their solutions do. Okay. So that was solving a quadratic when we had a perfect square. Okay, that's going to be our process after we complete the square. But it's going to be only a few times that we will be given a perfect square to start with. A lot of the times we'll be forced to make our own perfect square. Okay. And so I'm going to show you how to complete the square. That's what we mean. We're going to how to make a perfect square, or complete the square, in order to solve a quadratic. Okay, so number 3, 4, I have a couple more not shown on this page. Are examples where we will have to complete the square. Alright, so in order to complete the square, these are the steps that we're going to take. When we complete the square, what we want is we want to make sure we have a and b on this side. Okay, so I'm going to have x plus 12x here. I'm going to move the 13 to the other side. Okay, because right now it's kind of just in the way. I'll move that to that side. Okay. And I really want to add a number here that makes this side a perfect square. Okay. And algebra rules will tell us if I'm adding something to the left side, I need to make sure that I'm adding something to the right side. So I'm just going to have that space here. Alright, now this is how we'll find this number. This number will always be, and I'm going to write this up here, x plus ax squared plus bx plus, okay, this number will always be b over 2 squared. It's going to always be b over 2 squared. And the reason that we have to do that is we're going to try to find out what number can we have to be the same in both binomials. Okay, what two numbers add up to give us 12 and are the same number? That's going to be 6. 6 plus 6 is 12, so here it should say, what's 6 times 6? Well, it's 36. Okay, and so what we did on this side is we completed a perfect square. This will be x plus 6 squared. Okay, we knew it was 6 because that's the number we said what adds to itself to get 12. 6. So x plus 6 squared equals 49. We can now, that this is a perfect square, take the square root of both sides, and we'll get x plus 6 equals plus or minus 7. To get x by itself on both sides, I'll subtract 6. So x equals negative 6 plus 7. And x equals negative 6 minus 7. And so now I'll do these out. X will equal 1 and negative 13. And there's our solution. Alright, if you want to give that a shot by yourself, you can go ahead and pause it and try to see if you got it. If not, go ahead and continue to follow along with me. Alright, so for number 4, again, we're going to do the same thing. This c is kind of just in our way, and so we're going to move it out of the way. I'm going to have x squared minus 20x plus some unknown number, because I'm moving this c to the other side, minus 32, plus that same unknown number at this point. Okay, again, my question is, what plus itself equals negative 20? And that'll be negative 10. Okay, this will come here is what's that number times itself. Negative 10 times negative 10 is 100. You notice I already wrote the plus. I already wrote the plus because I know it's going to be positive, because it's either going to be 2 negatives or 2 positives, which makes this product number always positive. Alright, so here we go. We completed this square. We used the number negative 10, so I have x minus 10 squared equals negative 32 plus 100 is 68. Sweet. Okay, and now I'll take the square root of both of these. Square root, square root. So I have x minus 10 equals radical 68. I'm going to use my calculator. 68, square root of that is 8.25. Okay, so plus or minus 8.25. I could just use radical 68, right? 34 times 2, 4 radical 17, 2 radical 17. Yeah, let's do that. 4 and 17, 17's prime, 2 and 2, because this is not a pretty number. Alright, 2 radical 17. Alright, so I have x minus 10 equals plus or minus 2 radical 17. But I don't care what x minus 10 is. I want to know what x is. So I'm going to add 10 to both sides. So x equals 10 plus 2 radical 17. And 10 minus 2 radical 17. Okay, remember from our radical chapter that we can't simplify this any further because they're not like terms. They don't have the same radicals. So here's our final answer. Not pretty, but we know exactly what it is. Alright. Sorry, guys. Alright. You change that to equals 16, and then we can try this out. Alright, sorry about that. X squared minus 14x equals 16, and then we have x squared plus 9x equals 136. Try these out on your own, see if you got this. 6 might be a little bit confusing, but it'll be the same process, even though you'll have a decimal. Okay, so here we go, number 5. On this left side, I'm going to complete the square. I have x squared minus 14x. I'm going to give myself a little bit of space for this term to complete the square. 16 plus, again, that space to complete the square on the left side. Alright, so 14. This is going to be half of 14 squared. So that's 7 squared, that's 49. We'll do the same thing here, 49. And I know that this will be x minus 7 squared. This will be 65. Okay, I'm going to take the square root of both sides. And that cancels it out here and leaves me with x minus 7 equals plus or minus radical 65. Okay, if I tried to break that down, that's 13 and 5. They're both prime numbers. I know it's really close to 8. Okay, to get x all the way by itself, I'm going to add 7 to both sides, and so x will equal 7 plus or minus radical 65. Okay, that's the same as me saying 7 plus radical 65 and 7 minus radical 65. Okay, so it should be about 15 and negative 1. Okay, if you're asked to put it to the nearest tenth, you can do that by typing it into your calculator as I showed you earlier. Alright, last problem, let's do that with number 6. We got x squared plus 9x equals 136. X squared plus 9x plus whatever is going to complete this square will equal 136 plus that same thing. Okay, now this is a little bit tricky because this is going to give us a decimal, okay, a 4.5 or a fraction, and I prefer a fraction. Remember earlier I said it's always going to be b over 2 squared. So I'm going to say 9 over 2 squared. 9 over 2 squared. Alright, and that will give us x squared plus 9x plus 81 over 4 equals 136 plus 81 over 4. Alright, now don't let it confuse you on this left side, because this left side, we did this on purpose. We know that this is always going to be x plus whatever number this is. In this case, it's 9 over 2 squared. Just like here, it was negative 7 squared, and negative 7 became here. This is 9 over 2 squared, 9 over 2 is here. Okay, now on the right side, though, we do have to worry about it a little bit because we have to add fractions. And you know that when you're adding fractions, you need to have a common denominator. So no, this is no longer 136 over 1. It should be, you have to multiply both sides by 4, numerator and denominator, find out what it is. And that's like, and that is, I'm going to type up my calculator really quick, 136 times 4, 544. Okay, so 544 over 4 plus 81 over 4. If we add that together, it's like 625 over 4. Okay. Okay, so adds a little bit to it. 625 over 4 equals x squared plus 9, x plus 9 over 2 squared. Okay, I'm going to take the square root of both sides, which we can do a little bit easier because these are fractions. On the left side, we have x plus 9 over 2. On the right side, we have plus or minus radical 625. I believe it's 25. Yep. Okay. Plus or minus 25 over 2. So, to get x all the way by itself, last step, I know it's been a long journey here. I am going to subtract 9/2 x, so I have negative 9/2 plus or minus 25 over 2. Okay, you could have these as decimals if you'd like. You can keep them as fractions, but Negative 9 plus 25 would give us 16. Alright, 16 over 2. And negative 9 minus 25 would give us negative 34 over 2. Okay, and so that was break down to give us 8 and negative 17. Wow. Fractions the whole time, and they came out to be whole numbers. Okay, that is completing the square. Now one takeaway. You see how much shorter this problem was when our b value was even. Okay? Usually that's an indicator of if we want to complete the square or not. Okay, if our b value is even, then sometimes it can make it shorter than factoring. If our b value is odd, it kind of can make it a more difficult and involved process. But now you know how to complete the square. Okay. All right. Have a good one.